Hi, our friend Jacob just broke his foot, and he is learning a little bit about what it is like to be disabled.
Oh, that's too bad, but at least his foot will be well soon.
He really wants to come into the treehouse, but it's not wheelchair accessible. Have you experienced that?
Yes, a lot of places are not built to accommodate people who are in wheelchairs or have other disabilities. But today, public places are required by law to be accessible to everyone.
I didn't know that there were laws that require buildings to be accessible to everyone. What can you do to make buildings accessible to people with disabilities?
Well, a lot of buildings use simple machines, such as a ramp, which is an inclined plane. Some use elevators, but they are a little more complex.
We need to keep it simple. What is a simple machine?
A simple machine is a device that makes work more convenient by changing the speed, direction, or amount of force. There are 6 simple machines: inclined plane, levers, wheel and axle, wedge, pulley, and a screw.
We are thinking that a ramp might be the answer to our problem, but we didn't know that they were simple machines. Are there any requirements for ramps?
If you want to build Jacob a ramp to get into the treehouse, the ramp will need to be built at a 12-to-1 ratio.
That really helps. It gives us a lot to think about. See you later.
I wonder if there are any other simple machines we need to use to solve our problem.
We need to do more research. Look, Dr. D's bouncing up on that big ball.
I hope he doesn't fall off.
Hi, Dr. D. It looks like you're having a great time.
Hey, I'll be right there. There's a lot of science here at the Circus Center.
Science? I never knew that there could be science at a circus.
Sure there is. Circus is a great place to get some ideas to help you solve your problem.
We're particularly interested in simple machines.
Great. Right now they're using a teeterboard, which is a lever with a fulcrum or rotational point in the middle.
How does it work?
Well, let's watch them.
That was pretty neat.
I noticed that 2 men jumped on the board, but only one flew into the air.
Those 2 men that jumped are called pitchers. The one that flew up in the air is called a flyer.
I should have guessed that one.
After the pitchers jump, they have a lot of potential energy.
It looked like the flyer went at least twice as high as the pitchers.
Exactly. 2 men have the same energy as 1 man twice as high. The flyer also helps by pushing off the board.
So the lever didn't create any energy.
That's right.
The lever changes the downward motion of the pitchers to the upward motion of the flyers.
Correct. It's not magic. The teeterboard just lets them transfer energy from the pitchers to the flyers. How would you like to experience the flying trapeze?
That would be so cool.
Now, what does the flying trapeze have to do with energy?
When you are way up there on the platform waiting, you have a lot of potential energy.
Then when you grab the trapeze and swing down, you build up kinetic energy.
And when you swing back again, you lose kinetic energy and pick up potential energy.
Very good. So energy isn't being transferred like on the teeterboard. It's just changing from potential energy to kinetic energy and then back again. That's why it's the acrobats on the aerial hoop. These guys are really something.
Someone will have to do a lot of work to lift the hoop and the acrobat together.
It looks really easy to pull them up. What are they using with the rope?
It looks like they're using pulleys attached to the rope.
I think this just might be the thing we need to pull Jacob up into the treehouse. This is great. We're making some real progress. Thanks, Dr. D.
You're welcome. Let's see about trapeze training.